Gravity. By definition will be what? What force? mg times what? Delta y. Cosine of what angle between mg and delta y if the elevator or the object is going upward? 180. Cosine of 180? Negative 1. So will be cosine of 180. This is negative mg delta y. So is the gravity taking up energy or giving energy? When you are going up the stairs, is taking energy from you or giving energy to you? Taking energy. So you can feel when you are going up the stairs, you feel like you are giving up energy because of the gravity. When you are going down though, what is happening? It's giving to you energy, right? And you fly the stairs down, okay? Because it's given to you energy. Okay, this is how to solve this problem. How can we find the network? Good. And finally, so we have already one problem. When the object is moving horizontally, when the object is moving vertically, and now a combination of both. Where usually we combine the x and the y? In what type of problem? Incline. So the same question, the same type of question, but on the inclined plane. So let's say, and all these problems, so if you look here, energy and energy transfer here, in the study guide, the first question, if you look at the study guide, in the study guide, when we have question number 1, you can see I give a constant force of 12 Newton in the positive x direction. Acts on a 4 kilogram object as it moves from the origin to the point 6i minus 8j. How much work is done by the given force during this displacement? What I am giving to you? The force, which is constant. And I give the displacement. The force is only along x, correct? And the displacement is along x and y. How can I find the work? What definition do I use? What is work by definition if the force is constant? F times the number. Here we have delta r. We have the object is moving along x and y. Right? So what will be by definition? What did I say that is work? Work is either, if it's not constant, the integral, and if it's constant, F delta R. What is the scalar product of F delta R? F is along X, so will be 12I. How can I multiply scalarly two vectors? 12I times 6I minus 8J. How can I get that? Will be 12 times what? If it's 12 Newton I, when you multiply I with I, you get 1. I with J, you get what?
0.
0. This is the scalar product. This is not the vector product, scalar. So, what will be? 12 times what? 6. So, 12 times 6 will be the answer, right? This is just an example where we apply the scalar product. Then, you can see, if we go to question number 3, it's the same than this one, except that I am moving at constant speed. Right? So, question 3, I ask how much work is done by a person lifting a 2 kilogram object from the bottom of a well at a constant speed of 2 meters per second for 5 seconds. So we are looking for the work by the person lifting a 2 kilogram object. It's not like this one, but I am looking for the force done by the person, the work done by the person. is given the force done by the person. In the question, is given the force done by the person. What?
2 kilograms.
No, that's not the force done by the person. What is that? Hmm? That's the mass of the object. The mass of the object. Right? So how can I find the force that I am doing if I am moving this at constant speed? How can I find the force done by me if I am moving this at constant speed? Which Newton law we apply? The first is moving at constant speed. If it's moving at constant speed, my force will be equal to what? No. The net force will be equal to 0. One thing is the net force. One thing is my force. My force cannot be 0. I am doing force. My force. Which Newton law you apply? The first. When you draw the free body diagram, what forces are acting here? F and gravity down. So what will be F? I am looking for my force. So force minus what? I am not talking about the work. I am looking about asking for the force, specifically the force. When we need to find the force, we apply the Newton law, correct? I am applying a force. I don't have my force, but I have the mass of this object. So draw the free body diagram. Tell me what forces. F minus Fg equal to what? 0. What will be F? Mg. Because it's moving at constant speed. If I am accelerating, will be F minus Mg equal to Ma. So I can find F. You understand? But I am not giving the acceleration. I am telling you that the object is moving at constant speed. So if it's moving at constant speed, you need to know that the only way to find the force is applying Newton laws. Which one? First, F minus Mg equal to 0. So F has to be equal to Mg. Got it? And now you can find the work. What will be the work? The force, my force, which is Mg, times what? What delta?
Delta R.
Which is in this case what? X or Y?
1.
Delta Y times what? Cosine of what angle? My force is up and delta Y is up. What is the angle between them?
0.
0. That's it. That's the way you find the work. Got it? So it's application of what we are learning here. Now, if you look, the next question, question number 4. You cannot answer that question yet because we didn't talk about kinetic energy yet. I didn't talk about kinetic energy. But we go, yes.
I have a question to the last one we did.
Yes.
Because as you explained, it's like if the object is moving towards the y-axis, but here it says that
It's moving at constant speed for 2 meters per second for 5 seconds. But it's moving along Y.
okay.
Okay, the question number 5. Question number 5. I am just giving hints. This has to be done by you. Hints. An object moving along the x-axis is acted upon by a force Fx that varies with position as shown in the picture. Can you see the picture? Question number 5. What do you have? In the picture, what do you have? What type of graph? And what type? The variables that we have there, what are the variables? Force on y-axis and x on y-axis. What did I say here? That is the work if you need to find the work. Area under the curve. This is the concept you have to use. Area under the curve. So if the area is above the x-axis, will be positive work. If the area is below the x-axis, it will be a negative work. Did I say this in class? You have that concept there? This is the concept you have to apply here. Okay, number 6. A force is acting on an object, moving along the x-axis.